My presentation is on pollution abatement in the fruit canning industry. Specifically, I will be looking at ways to efficiently and effectively reduce wastewater generation, reuse recycle wastewater, and pre-treat wastewater with high organic material. In 2008, the Economic Research Service determined that the average American consumes 10 pounds of fruit annually. That's over 3 trillion pounds of fruit consumed in the US per year. With this demand comes pressure to adhere to constantly stricter discharge regulations and rising wastewater treatment plant surcharges. As a result, the industry is looking at new ways to reduce or remove the organic materials from wastewater. Organic material in the wastewater contributes to high levels of BOD, TSS, and excessive nutrient loading, namely nitrogen and phosphorus compounds. When BOD levels are high, the DO levels decrease because the available oxygen in the water is being consumed by the microorganisms. As DO levels in the water drop, aquatic life begins to suffer. With total suspended solids, suspended matter blocks the transmission of light, diminishing photosynthetic activity. The settled matter can cover the floor, damaging invertebrate populations and blocking spawning beds. Excessive nitrates and phosphates can result in overgrowth of aquatic plants, especially algae. This overgrowth means more organic waste in the water, resulting in a higher BOD. Also, algae blocks the transmission of light. Source reduction technologies, reuse recycling, and treatment technologies are 3 ways industry users can properly adhere to local and federal regulations. Source reduction is the first and most effective step in minimizing wastewater generation. It's decreasing the amount of waste generated. As less waste is generated, less wastewater has to be treated and discharged. Practical source reduction methods include keeping all dry waste dry and wet waste wet, and optimizing water usage during the fruit canning process, such as using pneumatic powered equipment rather than water powered equipment. Newer source reduction methods include process modeling, process sensors, and control in low or no water cooking and processing. These methods involve automation and process integration, which helps maximize efficiency of your operation. In some instances, wastewater can be reused, such as using the same batch of water multiple times for floor cleanup. Certain types of wastewater can be used for animal feeding. Also, organics within the wastewater can be used for composting. Finally, the treatment of wastewater. Current technologies include separation and biotreatment, while newer or emerging technologies include membrane applications and new sterilization methods. Separation uses drain screens, settling basins, berms, and other similar methods to separate waste products from the wastewater before ultimately discharging to the sewer system. Another existing technology is biotreatment with either suspended or attached growth microorganisms. Both aerobic and anaerobic technologies are used for treating this type of wastewater. A newer and emerging treatment technology is using a membrane application which captures and retains the dissolved solids or other constituents. Typically, the main issue with membranes is clogging as organic waste builds up on the membrane surface. As a result, new membrane applications have been designed, such as centrifugal and vibrational systems to limit clogging. Also, stainless steel and ceramic materials as membranes improve cleanability and the reuse of the membrane. Instead of using chlorine, which has byproducts and toxicity concerns for aquatic life, newer and emerging technologies such as ozonation and ultraviolet disinfection are now being used, which are more environmentally safe. In summary, these technologies can result in reductions of BOD surcharge, wastewater discharge volume charge, sludge volume, and labor, resulting in significant savings for the industry user over time. Cost aside, in order to meet the rising expectations of the customer and government regulators, significant efforts to further develop and integrate new technologies that reduce wastewater loadings, save energy, and protect the environment will be necessary.